Opie planted 20 seeds. He knows that, from previous data, 85% of the seeds of this plant germinate. Suggest a suitable model for the number of these seeds that germinate. Well, we have a fixed number of trials and a constant probability of success. So that suggests a binomial. So we'll say that x is a binomial with 20 trials and a probability of success of 0.85. Now we know that for a binomial NP, the mass function, the probability that x is equal to x, is ncx p to the x q to the n minus x, where q is 1 take away p. In other words, q is the probability of failure. So in this case, it would be 0.15. So for our case, the mass function is going to be 20cx, 0.85 to the x, 0.15 to the 20 take away x. So we want to find the probability that 16 seeds germinate. So that's the probability that x is equal to 16. So that's going to be 20c16 times 0.85 to the 16 times 0.15 to the power 4. So we can calculate that. So, sorry, I pressed that too early. So it's going to be 20, then C16 times 0.85 to the power 16 times 0.15 to the power 4. And that's 0.1821. Correct to 4 decimal places. For 20 seeds to germinate, that's the probability that x is equal to 20, which is 20c20, which we know is just 1, times 0.85 to the 20 times 0.15 to the 0, which is just 1. So this is just 0.85 to the 20. So 0.85 to the power 20, and that's 0.0388. Again, working to 4 decimal places. Less than 20 seeds germinate, so that's the probability that x is less than 20. Or another way of looking at it is that's the probability of x being between 0 and 19. Now that's 20 possibilities. We could work all of them out individually and add them together, but that's a lot of work. So can we do that more easily? Well, if we think of all of the cases from none to 20, we know that the total probability there must be 1, because it's absolutely certain that one of them is going to happen. So we can do this as 1 take away the only case that we don't want. So 0.0388. And we'll just calculate that. So 1 take away 0.0388, 0.9612. Again, to 4 decimal places.